what we're going to look at is something that perhaps defies all language or definition, which is consciousness. And let's just clear the ground a little bit. Before you expect or hope that I'm going to define consciousness, let me say that's really very hard to do, because normally when we define something, we do an operational definition. Love is when I give my mother 10 red roses. Or it can be you refer to a higher set. A chair is a piece of furniture. Now, neither of those typical strategies work with consciousness. It's a what? What's higher than that? It's a property of the brain that doesn't really work. Or consciousness is when what? You can just lie there, eyes closed. And many of you here are very kindly, nice and quiet and so on, and I hope you're still conscious. So we can't use those strategies. So I'd like to just put to one side the classic problem of, well, how are you going to define consciousness? Let's not try, yeah? Let's not try. Let's just say, we all know what we mean, don't we? It's what hopefully you're experiencing at this very moment. This amazing, bizarre phenomena. I mean, if I said to you now, actually on my way here, I did discover how the brain generates consciousness. What would you be expecting me to show you? What kind of answer could satisfy that question of how the brain generates consciousness, even in our wildest science fiction, hypothetical, infinite resource world? I don't think we can address that. So we're not going to. And what we're going to do is we're going to adopt the stance of the neuroscientist, which is looking at the bump and grind of the brain cells. And I thought a nice way of doing it and showing what neuroscientists can contribute to this really, perhaps the biggest question anyone can ask and the most unfathomable. The way to do it perhaps would be to take you through a typical day where different things happen to you. And that's what my book is about. In English, it's A Day in the Life of the Brain. I gather in Hungarian, it's something like The Brain's 24 Hours or something like that. But you can get the idea. It's the sort of same. And what we're going to do is go through your day, as you can see here. But before we start, let me just show. I'm sure many of you certainly citizens seen the brain. But for those of you who haven't, can you imagine what it's like to dissect a human brain and hold it in one hand? Can you imagine that? And when I first did that, I thought, what would happen if I got a bit under my fingernail? Would that be a memory? Can you have a memory under your finger? Could you have love under your fingernail? Or could you have a habit like biting your fingernail under your fingernail? Yeah? So that's the kind of problem we're facing. You get the idea, right? I think perhaps the biggest challenge to anyone with a theory of consciousness comes at the beginning of our day. How does an alarm clock wake you up? There you are, you're unconscious, and then there's an alarm clock, and suddenly you're conscious. So surely any theory of consciousness should be able to explain that. Well, let's think about unconsciousness, because it's quite interesting. As you may be aware, you're not unconscious and then awake. You can actually have stages of consciousness, as shown here. And the little red, which we'll come to later, is so-called rapid eye movement, REM sleep, which is the dreaming state. So unconsciousness is graded. And interestingly enough, the other form of unconsciousness which we're familiar with, which is anesthesia, that too is graded. So I was thinking about this on holiday once by the swimming pool, and I thought, well, if unconsciousness can be continuously variable, if it can be graded, comes in degrees, what if consciousness was also coming in degrees? Now, why that would be helpful for a scientist is, as you know, we like to measure things. We like to quantify things. So instead of thinking of it as some magic phenomena, if it was something that could vary in degrees, perhaps we can go to the brain and with a shopping list and say, look, is there anything happening in the brain that varies from 1 second to the next in degree, in amount? Okay, could it be, therefore, could consciousness be a bit like a dimmer switch? Okay, so that means that as a child, you're perhaps not as conscious as an adult, but when you're conscious as an adult even, you can be more conscious sometimes than at other times. For example, when you go to a lake or a mountain or a cathedral, you can be more conscious, and you're raising your consciousness, aren't you? Or you're deepening your consciousness. So it seems a plausible idea that we now need to think of a process in the brain. It can be continuously variable. And an image that came to mind was a bit like ripples. You know? So when you throw a stone, the stone is fixed and pretty permanent, but the ripples are highly evanescent, highly transient, but they stretch for much further than the diameter of the stone. So is there anything in the brain, this is a rhetorical question, because obviously there is, you could have something in the brain that's happening like that. So let me introduce you to something that we've been working on in my lab, and which is a technique that I find very exciting, which is optical imaging in the brain on a sub-second level. That's looking at the brain at thousandths of a second, which is commensurate with the electrical blips that brain cells use. And when you do that, I hope you can see the analogy with the puddle wasn't haphazard, it was deliberate. You can see here over 18 milliseconds, that's 18 thousandths of a second, going from the top left to the bottom right, that it is like throwing a stone. You can have a stimulus, very brief one, that then activates a large group of cells. We call them assemblies. They can be called anything, but large groups of cells are recruited for less than a second. For those of you who are interested, and you'll see in the book, these are 2 scientific reviews, but I'm not going to push the technicalities. Suffice it to say, we're looking for the equivalent of a stone in the puddle in the brain, and the ripples from that puddle are the equivalent of these so-called assemblies. So let's see how that holds true. For example, with anesthesia. This experiment we did in the rat, and you can see here with light anesthesia, the assembly is larger and stronger than as we deepen the anesthesia. So far, so good. We seem to have this idea of the ripples in the brain. So what we can do then is think about the wider the ripples, the deeper the consciousness. Now, having this image of a stone being thrown into a puddle means we can dissect it in various ways. The size of the stone, the force of the throw, the ease with which the ripples spread. So let's do that by now going through your day. Let's start now. We're going to have breakfast. Now, breakfast is a strongly sensory experience. You are stimulating the food, and it's a taste in and of itself. It doesn't stand for anything. It's just a lovely, simple taste that a child would like and animals would like. Perhaps what's less well known is that the senses synergize. So, for example, hot chocolate will taste more chocolatey in an orange cup. Perhaps you didn't know this. So if you want to save money on chocolate, mums and dads, you can invest in an orange cup and dilute the hot chocolate. Smell and taste will synergize, as indeed hearing and vision. We know immediately that with lip sync it makes life much easier. Because it's raw sensation, I'm going to argue this is the equivalent of throwing the stone. It's the force of the throw. So it's nothing magical, it's just the louder the alarm clock, the stronger the force of the throw, and that will generate the ripples. So that's what I'm suggesting. Intensity of subjective sensation, that's what you're feeling, is related to the degree of neuronal activity, how forceful the cells are being stimulated. Okay, so you've had breakfast. Now you're going to walk the dog. So is the dog conscious like you are? What can we say about the dog? Well, I love this picture because the dog is doing something that's outside of the canine repertoire. It's doing a human thing. I mean, normally the dog would either bite the lady or run away, quite obviously. But is an animal conscious like we are? Well, I think if we adopt this notion again, that yes, a rat will be conscious, but not as conscious as a cat or a dog, and a cat or dog will be conscious, but not as conscious as a child or a human. Oh, sorry, children are human, of course, as a child or as an adult. Then that kind of answers that riddle. So anything with the nervous system, I'm suggesting, will be conscious. And that will include, much more controversially, the fetus. Because you have to argue that otherwise, when the fetus is born, does consciousness suddenly come on? It seems unlikely, because babies can be born at different times, and some are born by cesarean section. It makes much more sense that in the womb, gradually, consciousness grows as brains grow. And that obviously has impact for certain debates, but it's nonetheless, for these purposes, I think, answering the riddle of when consciousness comes. It grows slowly as the brains grow. Okay, so that's your dog. Your dog's conscious, but not as conscious as you are. But unlike the dog, you have to go to work. And here you are working. Now, how can the environment change your consciousness? Well, what's very interesting is that although human beings to greater or lesser extents can adapt to the environment, human beings do it better than anyone else. We do it superlatively, which is why we occupy more ecological niches than any other species on the planet. And when you're born with a pretty fair complement of brain cells, but even in the first 2 years of life, you can see the astonishing change in the postnatal growth of the human brain is the proliferation not of brain cells, but of the connections between them. And this means that even if you're a clone, an identical twin, you're going to have a unique pattern of brain cell connections. This is something called plasticity, not because the brain is made of plastic, but from the Greek plastikos, to be molded, because every moment you are alive as a human being, your experiences are going to literally leave their mark on your brain. Now, that happens with humans superlatively. It can also happen with rats, and here's an example. Obviously, with rats, you have to think about what sort of environment you can do, and a good one is a so-called enriched environment. And this is from my own lab, where you can see the rats having a lovely time. Look how happy they are. They know they're not in the control group, that's why they're having a really lovely time. And you can do that for about 3 weeks. It's kind of rat heaven. And then, when they sadly go to meet their maker, you can look at the brain cells. And this is a brain cell from an animal in the standard housing compared to one from the enriched. And you can see the interesting issue here is the branches, the so-called dendrites, are more extensive even after 3 weeks. And that is because stimulation of the brain, even in a rat, rather like with muscle, means that brain cells grow. In the case of brain cells, they go branches. Why is that interesting or important? Well, by growing branches, you are increasing the surface area of the cell, so now you can make more connections. Why would you want to make more connections? Well, think of this. If a child saw this, it's a gold shiny thing, it might want to put it in its mouth. It wouldn't mean anything. But as the weeks turn to months, turn to years, as it makes connections, as it has experiences that are mirrored in those configuration of brain cell connections, the child will learn this goes on a certain finger. And it only goes on a certain finger under certain circumstances. So the child will learn that if it sees someone with a ring on their finger like this, that will say something about them that is not at all apparent from the sensory properties of the object alone. Then they might have one of their own, and it might be the most important thing ever, irrespective of monetary value, because of the associations it triggers. Meanwhile, a child would just want to put it in its mouth. So connections mean that you can escape from a sensory evaluation of the world to a cognitive one, from the Latin cogito, I think. Connections also help you out with things like this. This is a ghost, in case you haven't seen one recently. You're not frightened, but if I'd come on going woo, 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 like this to a small child or someone with dementia, they would be frightened, because connections enable you to see beyond the sensory evaluation, whereas someone without the connections, a small child, or very sadly someone with dementia where they've been dismantled, they have to take the world at face value, so they see a ghost and they're frightened. Yeah? So connections enable you to navigate the world, to personalize everything around it in the light of previous experiences, and also to see beyond face value evaluation. So here you are going through your life, and when you have a beginning, a middle, and end, a life story, which gives you an identity, which makes you the person you are. And it's all due to the individual connections in your brain cells, as shown here. And I'm suggesting to you that that is going to be the size of the stone in each case. So the mind can be differentiated from consciousness. I want to suggest it is the personalization of the physical brain through the unique dynamic configurations of the personal experiences that you've had. Okay, so if that's the mind, you can see here, we looked at, this is the animals in the control condition, that's the assemblers. You can see in the long term, clearly the stone will be getting bigger because they're having a enriched experience. Now you're going home. Here you are, going home, miserable time. Yeah. What awaits you? Well, your mood. So mood, whether you're excited or depressed, are determined by these chemical fountains, as shown here: noradrenaline, serotonin, acetylcholine, dopamine. I'm sure you've heard of these. And these will reflect your mood levels, your arousal levels or excitement. Particularly high of these chemical fountains that gives you arousal, which is also a chemical that is released during addiction, which also underlies reward, is one I'm sure you've all heard of called dopamine. And dopamine fountains out from the back of the brain and does many things, but I want to focus on it blocking something called the prefrontal cortex, the frontal part of your brain. Why am I talking about that? Well, what's really interesting is when it's inhibited, as with dopamine, then this sort of thing happens. This is from a play by Euripides, the ancient Greek playwright, where there's poor King Pentheus in a play called the Bacchae. He's about to be torn apart by these wine-crazed women. Look at them, they're really abandoned. They've been drinking too much wine as they worship the wine god Dionysus. They're about to tear him apart. And the whole point of this, which Euripides, 450 years BC ago, wanted to point out, is that sometimes we want to do this. Sometimes we don't want to have these carefully curated, personalized life stories. Sometimes we want to do this. We want to let ourselves go. We want to blow our minds. We want to have a sensational time. I gather you say the same in Hungarian. If I said, now let's go out and have a cognitive time, no one's going to come. Yeah, you have a sensational time. You pay money to be out of control. And the way this is done in the human brain is by enabling or disactivating the prefrontal cortex. So for these strong feelings, you can see that you're sensory, you're in the here and now, external stimuli are driving it, the world has little meaning. You're abandoned. You always know when you're dancing, the worst thing is to be self-conscious. There's no time or space. This is mainly infants and children normally. They don't have a fully developed prefrontal cortex, as opposed to the cognitive, fully fledged adult. And what's really interesting is children have the biggest surge of dopamine they'll ever have in the brain, and we have far less. So you can see it's a perfect push-pull. You have excess dopamine, which anyway inhibits the prefrontal cortex, and for the infants, in any event, that is under-functioning. So I'm arguing this will be a small assembly, as with children, and then you'll have the large stone, the large assembly. So now you're going off to bed, okay? But we've seen consciousness is variable. So what about dreaming? What about these dreaming states? Okay, well, what we can look at are the things, we've seen the force of the throw, that's degree of neuronal activity. I've now also argued that significance, the extent of pre-existing associations, is the size of the stone. And then finally, the availability of chemicals such as dopamine, which will make it easier or less easy for the excursions, the so-called viscosity, we can think of it as the fluid. Now, in all those cases, one can argue that they are turned down, so the small assembly will be low, and hence, in dreaming, it will be a form of consciousness, but very small assemblies. And then one has to think, again, for people who think we're going to be suddenly being kept as household pets by AI systems, and they're going to run the world, our brains are very different. We have a central nervous system, an endocrine system, an immune system, otherwise you'd have biological anarchy, and they are all interlinked. Now, I haven't answered how consciousness is generated. I've done a very brief zip through your day. The book goes into much more detail. But for the future, who knows? I think we'll get more and more correlations. And as you go to bed and you contemplate consciousness, always remember, tomorrow is another day. Thank you very much.
That was wonderful. Thank you so much. It is now time for questions. So if you guys have any questions, please raise your hand so I can spot you guys.
So as you were detailing, as the ripples of consciousness growing, there's kind of a fractal pattern that you can see as similar things revealing themselves at different scales. And I heard like recently a pretty interesting talk on this, but applied to AI. And I was wondering, what's the state of the science on understanding consciousness as kind of a fractal pattern effect on different levels?
Okay, so it depends what you mean by understanding consciousness. And as I said at the beginning, what is it that you're actually asking when you understand consciousness? And I think I can't see how fractals or quantum theory or any other very sophisticated physics or technology such as AI, I cannot see how that will get around the absolute central problem of how the water is turned into wine. That is to say, how the objective physical events get somehow morphed into subjective sensation. And I think that is the hard problem. And whilst there's some very elegant techniques to looking at the brain and studying it, is indeed our own optical imaging, I'm not having any pretensions that that is answering that question at all. And to my mind, I think it's still something that keeps me awake at night.
Great question, Dawn. Fantastic answer.
I'm really curious about how it's helped this thing what you working for in the trauma therapy. Because if somebody have a deep trauma, it's caused many things in the brain. So there is something like books or something what I can read about in this topic.
Okay, so I don't work directly with clinicians on trauma therapy, but if one uses this model to interpret depths of consciousness, if something is a persistent state of consciousness, I would argue that that is a large assembly which is very resilient to being displaced by other things, and that's why it's so distressing, because it's there and it's constant. So as with speaking therapists for depression, for example, what they do is you rearrange the connections. That's what you're doing when you do it. I would counsel that rather than necessarily taking drugs, which won't change the situation. It'll just be a temporary kind of hold. But I haven't answered your question very well. But if you get the book, not that I want you to get the book, you'll see there's more data on clinical states and how they relate to consciousness.
Thanks for your question. Do we have any on this side? Yes, we've got some people over there. White cardigan.
I recently started reading your book, and in the beginning you mentioned that you started your university by studying history, and you made a really big change. And I'm wondering a bit more about that and how you came to the decision to start learning about neuroscience.
Okay, thank you for that. I'll try and answer it briefly, given you're asking me. So it wasn't history, it was ancient history. And you might have guessed from the way I showed the example from Euripides' Bacchae that I did ancient Greek as well. So I did ancient Greek, Latin, ancient history, and pure maths for my studies, yeah? And when I went to Oxford, it was to do philosophy. So I've always been interested in what I now recognize as philosophy of mind. Sadly, that wasn't on the cards. The way Oxford University taught philosophy was linguistic, and it was formal logic, and having done maths, that wasn't a challenge. So I was more interested then in psychology, and then I drifted into physiology and ended up doing neuroscience with no qualifications whatsoever. But I think that gave me the opportunity not to be worried by dogma, because I didn't know the dogma in the first place. So it enabled me to ask sort of emperor's new clothes type questions in a way that someone with a more conventional education would have done. But I've never regretted doing what's called the classics. That's Latin, Greek, and ancient history. I think it gives you a really strong confidence to do things. And in a sense, it's full circle, because the kind of questions that Euripides was posing, like these two forces, what he called the wine force and the bread force, the desire to be a person, to be an individual, to have a past, a present, and a future, is in direct conflict with the desire to let yourself go with wine, women, and song, or drugs and sex and rock and roll, and to be abandoned. And that is a theme that was explored, say, 450 BC in the Bacchae. So for me, intellectually, there was a continuity between what I'd done with Latin and Greek and then what I did with neuroscience. The two are very close in a way.
Great question. Thank you. Do we have any more questions?
You talked about how experiences form the neural connections in the brain, right? And that's why I'm wondering, is there a direct connection between neuroscience and psychology? Do you see a future in that?
Oh, well, there's always been a connection. I mean, Freud himself, was first a neurologist before he became a psychiatrist. So, yes, there's always been a connection. It's just psychology will deal more with subjective reports and behaviors, whereas traditionally people like me deal with the mechanics of how brain cells work. But I think the two work together, and it's a very graded phenomena. So in any respectable neuroscience, you'll have people that work at the what's called top-down as opposed to bottom-up level. Top-down being behavior and subjective reports, and then bottom-up is the squalor of the physical chemicals of the brain. And the big problem, actually, is where they meet in the middle, and that's where I like very much working on these assemblies, because traditionally people who work with gross brain regions or behaviors don't have much in common with people working with action potentials and calcium currents and receptors and so on. But I think by looking at this mid-level, this mesoscale level of assemblies, that could be a way for the two to actually have common ground.
Yes, we've got some people in the front row over here.
We see in some pictures that during sleep, it's a lot of process going on in our brain. And many of us try to get forward in life, work hard, and whatsoever. And how big importance sleeping and resting enough is in our life. So we should make it a big deal and really consider it to have enough time, and we can perform better, or it doesn't have that much effect.
Well, it depends on each individual. I mean, Margaret Thatcher and Churchill traditionally only needed 4 hours sleep a night, they claimed. One of my bosses, when I worked in New York, said, well, there's plenty of time for sleeping when you're dead, he said, which wasn't a very helpful kind as we worked till 2 in the morning. I think the comment, obviously, everyone says you need to get good sleep and you need to rest. If you're sleep deprived, you start to hallucinate and you make poor decisions and you can't focus and so on. But different people need different amounts of sleep. And for me, I would say, if you're tired, you're not getting enough sleep. And if you're not tired and you feel great, then you are getting enough sleep. So I'd leave it as simple as that. But certainly sleep is really important, yes.
Give it up for Baroness Susan Greenfield,
Thank you very much.
everybody.